Okay, so the second thing we're going to do is we're going to look at another way of doing elimination. We're going to use something called Gaussian elimination. So this is just a way of organizing big elimination problems and something that's a little bit easier to work with. So we're going to start by doing it on a 2x2 here, even though it's kind of overkill for this. So we're just going to do it so you can kind of see the process. All right, so we start with a 2x2. We have x minus 2y equals -6. We have 2x plus 3y equals 2. We could solve this any of the ways that we did in class. We can do graphing, we could do substitution, we could do elimination, whatever. So Gaussian elimination is a kind of a formal way of writing out elimination as a process. So we're going to kind of look at how it mirrors elimination. So when we do elimination, what we typically do is we'd use this x to cancel out that 2. So on that process, I would have said -2 times that whole first row, x minus 2y equals -6, and that would have become -2x plus 4y equals 12. So I would have multiplied that whole thing by -2, and then we would add it to the other equation. That was kind of how we did our elimination. That way our 2's canceled. We got 7y equals 14. And then we could actually solve that and we would get y equals 2. Once we had that, we'd plug it back in, going backwards into the originals. So we'd have x minus, well, our y is 2 times our y, which was 2, equals -6. We get x minus 4 equals -6. And we would get our x equals 2. So our final answer would be our 2 in this case. So that was kind of what we did before. -2. So now let's kind of look at how that looks doing Gaussian elimination. So our first step is we're going to convert this into an array of just numbers. We don't want the letters to confuse us. We just want some numbers to work with. As you've always complained, oh, why did they put the letters in? That's what we're going to do here is we're going to take the letters back out. So I'm going to set up what's called a matrix. A matrix is just an ordered array of numbers. We're going to break it all up into rows and columns, and it's going to exactly match the coefficients that we have here. So when we do this, it's important that we have our x's are in a column, our y's are in a column, our other numbers are in a column. We have to maintain that same order. So we have 1x on top and a 2x on the bottom one. We have -2y's, we have 3y's. We have -6 and we have 2. So now we've written it as an ordered array or a matrix. So this we can now do a whole bunch of work with. We can do all the same stuff that we talked about before. So this just represents these rows. So just like we can multiply everything in here by a number, we can multiply an entire row in here by a number. Just like over here, we can add two things together, we can add rows together. We can subtract rows. We can do pretty much anything we want. So when we looked at elimination, what we did before is we eliminated one of the variables. And that's what Gaussian elimination is going to have us do, is we're going to work our way down eliminating all other variables until we get something where we can just get the number. In particular, that means we need to eliminate this spot right here. This is the x that we eliminated for this problem. So that's what we need to eliminate here. So it's easy enough to see what we did here. That's why we did it first. We're going to kind of mirror that. Because it's just numbers, it can kind of be hard to tell exactly what you did. So I like to use a little notation to show exactly what steps I did. So if this was my row 1, this is my row 2. So what we did over here is we said -2 times that first row. So -2 times that first row. And then we added it to our second row. And that's exactly the work we did right here. The only thing I'm going to add now is I can say that when we do a combination, it can replace one of our rows. So I'm going to say that's become a whole new row 2 when we do that work. So let's see what that would look like. Again, we're just mirroring the exact steps we did over here. So I'm not permanently changing row 1. I'm only permanently changing my second row. We're making a new row 2. So I still have my 1, my -2, and my -6. So we're saying we're going to do -2 times row 1 and then add it to row 2. So -2 times 1 is -2, plus 2 is our 0, and that's what we want. -2 times -2 is 4, plus 3 is 7. -2 times -6 is 12, plus 2 is 14. And notice this is exactly matching this row, what we got right here. There's no more x's. This would be 7y and a 14. This is our goal in Gaussian elimination. We're going to combine rows to make these lead coefficient zeros until we can just see a single letter and a single number. So remember, these correspond to our x's, our y's, and then just the numbers. So now we have just a single equation with a single letter in it. That means we can solve and work our way backwards. So just like here, we took our 7y equals 14 and we solved it. I'm going to take this row now and say, hey, that meant 7y equals 14, and I can solve it and get y equals 2. Then I can take that and I can plug it into our first one that we had. Remembered that this meant this was 1x minus 2y equals -6, but now we know y is -2. Sorry, 2. So that's x minus 2 times 2 equals -6. We get x minus 4 equals -6. We add our 4, and we get our x equals -2, just like we did with the elimination. So we got the same answer. This seems like more work because honestly, it is kind of more work when it's something really simple like this. I would not do Gaussian elimination on a 2x2. We worked through this so you can kind of see exactly what I'm doing and how it corresponds to what we've done before. Where Gaussian elimination comes in handy is when we work with bigger systems. So in the previous video, we did the substitution, and that got really crazy really fast. Gaussian elimination keeps things a little bit more organized. So let's actually try that out. So we're going to try a 3x3 with Gaussian elimination. All right, so we have a system. We have our x minus 2y minus 2z equals 6, 2x minus 3y minus 5z equals 7, 3x plus 4y plus z equals 2. All right, so substitution, we did that last time. Now we're going to try Gaussian elimination. So first thing I'm going to do is I'm going to make a matrix of this whole thing. So I have all my x's lined up, I have all my y's lined up, all my z's lined up, all my numbers. So I do my x's are my columns, 1, 2, 3, -2, -3, 4, -2, -5, 1, and 6, 7, 2. So all I've done is I've converted all those coefficients into just numbers, and this is our matrix. I'm going to number my rows to help me keep track of my work so I can figure out if I make a mistake somewhere. Okay, in our previous example, we only had 2 rows, so we only had to eliminate one thing. We're going to follow that same kind of pattern. I need to use this guy to eliminate everything underneath it. So we're always going to make a little pyramid of eliminations. So I need to make this one a 0, that one a 0, and that one a 0. And that's how I'll know when I'm done. So let's start by getting rid of this one. When we did elimination, when we looked at these, if I want to eliminate the x's, I would have to multiply this by -2, because -2 plus 2 would cancel out. So that's exactly what I'm going to do here. I'm going to say -2 times my first row. I'm going to add it to my second row, and it's going to become my new second row. So let's try that out. I'm only permanently changing my second row. So I have 1, -2, -2, 6. All right, so now we try it. -2 times 1 is -2, plus 2 is 0. And that's exactly what we wanted. -2 times -2 is 4, plus -3 is 1. -2 times -2 is 4, plus negative 5 is negative 1. Negative 2 times 6 is negative 12, plus 7 is negative 5. And then we didn't do anything with the last row. So I eliminated that first x in my second equation. Our next step, we need to eliminate the next x. We got to get rid of that 3. We're always going to eliminate down, and then we're going to eliminate the next one over. So to eliminate this 3, I would have to multiply the first row by 3. That would give me, or by negative 3. That would give me negative 3 plus 3 would cancel. So I'm going to say negative 3 times my first row plus my third row, and I'm going to make it a new third row. Again, this time I'm only permanently changing the third row. The first two are staying the same. So I have 1, negative 2, and 6. 0, 1, negative 5. Okay. So negative 3 times 1 is negative 3 plus 3 is 0. That's exactly what we want. Negative 3 times negative 2 is 6 plus 4 is 10. Negative 3 times negative 2 is 6, plus 1 is 7. Negative 3 times 6 is negative 18, plus 2 is negative 16. Hopefully I haven't made a mistake. It does happen. It's easy to make little errors as we go through. That's why we have the notation to check our work later. Okay, hopefully I haven't screwed it up. So our last step here is we need to get rid of this number next. Now to do that though, I can't use this equation anymore. If I were to do anything times this and add it to 0, we'd lose that 0. So I'm going to have to use only these two rows now. So if this is a 10, I'm going to say negative 10 times my row 2, adding to my row 3 to become a new row 3. Because negative 10 plus 10 will cancel out. Again, we're canceling our next step. So I'm not changing permanently row 1 or 2. So that's still 1, negative 2, 6, 0, 1, negative 5. But I'm getting a new row 3. Negative 10 times 0 is 0, plus 0 stayed 0. That's important. We needed it to stay 0. Negative 10 times 1 is negative 10, plus 10 is 0. All right, this is looking good. Negative 10 times negative 1 is 10, plus 7 is 17. Negative 10 times negative 5 is 50, plus negative 16 is 34. Okay, we're done with the matrices stuff. Our goal was to get this little triangle almost of zeros right here. Now if we look at this bottom row and we convert it back into letters, this is saying that 17z equals 34. We can now just get a number from it. Divide both sides, and I get z equals 2. I can now take that and we go up one stage. So just like our bottom one only had z, our next one up only has y and z. If we read that equation, that says y minus z equals negative 5. I now know z is 2, so I can plug it in. Y minus 2 equals negative 5. Add 2 to both sides, and I get y equals negative 3. Now I know z and y. I can plug them both into our first equation up there. So if I look across that row, that first equation reads x minus 2y minus 2z equals 6. But now we know what z and y equal. So I get x minus 2 times negative 3 minus 2 times 2 equals 6. So that's x plus 6 minus 4 equals 6. x plus 2 equals 6, and I get x equals 4. My final answer is 4, -3, 2. This is Gaussian elimination. So going back from the top, we took our system of equations, we made it into a matrix. It's just an ordered array showing the numbers. We did our elimination process just like we did with 2x2s in order to start eliminating. We always eliminate in a pattern. So starting from this first one, I need to get the ones below it as 0. So to get rid of this 2, I would have to say -2 times this and add it to that. So that's what I did. -2 times the first row, added to the second row, and I made it a new row 2. So that my row 1 stayed the same. I got -2 times 1 plus -2 is 0. -2 times -2 is 4, plus -3 is 1. -2 times -2 is 4, plus -5 is -1. -2 times 6 is -12, plus 7 is -5. So that's what I did. I combined the rows just like we did elimination before. I then, using this as my new system, eliminated the 3 through the same process. Then finally, once I had those 2 zeros, I have to make this last one a 0. So to do that, I need to use only row 2 and row 3 to cancel out that last spot. So we have, to get a 10 canceled, I'd have to multiply by -10. So we have -10 times 0 is 0, plus 0 stays 0. -10 times 1 is -10, plus 10 is 0. -10 times 1 is 10, plus 7 is 17. -10 times -5 is 50, plus -16 is 34. Once we have our little triangle of zeros, that means we're good, we're done, and we can read it off and convert back to equations. So that gave us 17z equals 34, so z equals 2. I plug it in going 1 up, because that's y minus z equals 5. And I can plug in the z value that we just got, which was 2. Solve that, and I get y equals -3. We can plug them both back in. This is basically elimination all the way through, but it enables us to keep it organized. I'm not assigning many of these problems for homework because, as you can see, it's a lot of work. However, our next class, I will show you how to do this one on your calculators. It's not a good way to do the substitution by calculator. We're going to have to keep doing that one by hand. All right.